Hey nerds, yeah, glad to be back. You won't believe this. This nasty bug had me again and I couldn't speak for a week. And this was no fun. This really was no fun. But I think now I really got it. And you think you move to the Canaries and you never get sick again. Not the case. Well, anyways, let's do some electronics. Yeah, and to start with, I'll simply have a website for you. Let's do this here. Let's type here over here, so http column dash dash, and let's try if this works. WebTemp. I'll give it a slash at the end. Let's see what happens. Yeah, and it's a website. Of course it's a website. You can tell by the way I typed this over here in the address bar that this is a local website. If you try this in your browser, this won't work, of course, because it's a local website. And yeah, this is a web thermometer. I think there's a typo. Well, anyways, it keeps track of the temperature, There's another button here. This is download logs. Let's have a look at this. This opens a second page, and you can tell by the name of the files over here that this is some database, something that keep tracks of about a week of data, I think. Yeah, let's check in one of those here. Let's open this one up, and you can see, yeah, it's pretty clear what's happening here. It starts at midnight here at 25.5 degrees, and when I scroll down here, yeah, we have a lot of temperature over here. There's currently around 25, and yeah, it's getting down right now. It's just turned 6 o'clock in the evening, and you can see, yeah, this simply keeps track of the temperature. All right, this isn't so hard, right? Now you think, okay, why are you showing me that? This is probably some Raspberry something that has a database and stuff, and it's probably a big project. And let me show you the hardware for that. Haha, tricked you, yeah. Okay, this is obviously not a Raspberry Pi something. This is a ESP01. So this is a ESP8266 on a really tiny board. If you look closer, there's a little red PCB under the black one that has a little USB port. This is a programming adapter. I use it in this case only to supply the power for the system here. The silver thing on the right side is a DS18b20. So it's a Dallas semiconductor temperature sensor in the metal version there. And you probably can tell the really ugly soldering job I did there is the power and the usual 4.7 k ohm resistor you need for the operation of the sensor. Let's talk about costs here. So the whole thing you see here, the adapter is about $1. The ESP, so the ESP01 you see on top of the little adapter is $150 round. And the temperature sensor depends on what version you get. This one is, I think, another $1. So you get away under $5 for the whole shebang. This is pretty cheap. But wait, Dad, didn't we see something like a file system? I mean, there were files you could download and files you can click on, multiple websites. Isn't there a server somewhere included? Don't we need a server for that? Well, let me show you. To find out where we stored the files that we saw before, I have here the official ESP8266 Arduino core documentation. This is at Read the Docs, and this is my go-to place if I want to find out anything around the 8266. ESP32 is the same. They have a really good documentation over here. So, where are my files? To understand this, we have to take a look at how is the flash memory. We have 1 meg of flash memory. Let me write this down. We have 1 meg of flash memory on an ESP01. This doesn't sound like a lot, and it isn't. But it's enough for what we're doing here. Let's take a peek down here at how the flash is layouted. Whatever. Of course, we need space to run off our program, the sketch. Let's say this is over here. If we want to do some over-the-air update, OTA, then we need space for that. It's probably the same as the main sketch, so this goes over there. And now it gets really interesting because look at this file system. This whole block over here is a file system by itself. It's normally not used. if you don't activate it. So this is where I store all the data that I get from the sensors, and it handles just like a normal flash drive, something. It has a directory, it has a folder structure if you want that. A bit further down on the page we find this table over here, and there you see my 1 megabyte here. Depending on how much space I put away for the over-the-air update and how big my program is, I'll get away with somewhere around 512 kilobytes to 164 kilobytes. Well, this doesn't sound that much. For our application, we get away with, I think, 144K. This is enough to save data for about a week. If you ever played around with file systems on a ESP anything, you probably came across SPI FFS. SPI is the protocol the flash chip is connected to the CPU. So this is a connection, and FFS is probably flash file system, something. And if you look a bit down on the page, you see this, and you see this nasty word here. So SPI FFS is deprecated. So anywhere in the future, a new update of the board's file, of the board's core, can break anything you write with SPI FFS. So it's not a good idea to use SPI FFS in a new project. And we won't do this because there is a successor. And the little successor over here is Little File System, Little FS. There should be compatibility between the two, but of course, Little File System is newer, supports real folders. I think it has wear leveling that could be a real factor for all the things you do with the little CPUs over here, because it's flash wears out, and I don't have any data on how long you can run this. But since Little File System is newer and has more functions, you will probably run into problems if you try to go backwards to SPI FFS. So you stuck with Little File System. Good news, Little File System is also available on an ESP32 and all the newer CPUs out there. It doesn't come with a CPU core. You simply find it over your library manager, so this should be doable. Right here, we know what file system we're going to use, and we know on what hardware we're running. I'd say let's dive into the code. So, and full disclosure over here, this project is a bit old for me. I wrote this about a year ago, so this isn't the latest. I would write it today. I probably will have some namespaces if I wrote it today, but you know me, I'm too lazy to fix this right now. Also, of course, 1.8.19. No, there's no 2.something IDE here. This is the old one. Live with this. The big upside, I can do a download of this whole project here. So you get the IDE together with the source code, with all the libraries, and I just checked it. It compiles over here. It loads up to the CPU. So you simply grab this, plug in an ESP8266 and go for it. Pretty any board with an ESP8266 on it will work. Over here under Tools, you can set the size of your flash memory. So say you have a WeMOS D1. This is normally a 4 megabyte flash chip on there. So you can go over here. So you can go over here and tell this thing, okay, use file system with 3 megabyte. This is probably enough for a month of data. I didn't check this. You have to do this for yourself. Another fair warning for you guys out there. This is a big project. This is software heavy. I have all the bells and whistles built in here that I came up at the time, and yeah, you would see this. There's a lot of going on. If you don't know your way around websites, HTML, client-server structures, this could be a bit much. But since it's a done project and you only want to have a data logger somewhere, just go for it and compile it. It will work. All right, to see what the thing is doing, I think it's a good way to imagine us being the CPU and simply going for the code like the CPU would do. So follow me on this really strange journey down into the rabbit hole. Starting over here with says config, we have a defined WLAN host name, and it's WebTemp. You can change this to anything you like. Maybe don't use spaces in there. That's not a good idea. Use underscores. This is the name your device will be available on your LAN. And it's the same name we use later for over-the-air update. Scrolling down a bit, we have a lot of includes over here. So this is everything we include over here. Let's start at the beginning. Of course, we need Wi-Fi here. We have a index HTML, and there you can tell, oh yeah, this is multi-tabbed. Over here is a lot of more stuff that we see later, and you can already tell index HTML. This is probably a website, something, WebSockets, Wi-Fi manager. Yeah, this is all coming up. We have include here with Wi-Fi manager. Then there's a little fs. We talked about this. This is a file system that I use to write the data into the flash memory. We have the over-the-air update over here. Yeah, of course, this thing is over the air. Of course, all the bells and whistles. This is a typical one for me. Helpers is something where I put all my little routines I need and don't want to have hanging around in the main code. So helpers, I store this stuff there. By the way, this is written DL_HTML. You can probably imagine this is a web page. So this is probably download.html something. The web server has its own H file, the download server has its own H file, and of course we're using WebSockets to do the communication between the browser and the little server. So we need this in there too. TZ is a system library, and it's time zones. This is the beauty of the ESP8266, how the NTP network time protocol is implemented over here, because all the time zones are already set in here. We don't need to worry about anything. This is totally easy. You'd see this in a minute. Starting over here is something simple because, yeah, it's a temperature sensor, so we need the one-wire bus and the Dallas temperature library. And over here we simply start the one-wire bus and get the sensor on the one wire. I won't go into detail on how to add a Dallas Semiconductor DS18b20 to any CPU. There are about a gazillion videos out there that shows you that. If you don't know how to add the sensor, please check YouTube. You are in the world's biggest library you can get today. This is something where I have to skip about for you a few details, because if I go into every deeper detail over here, this video will probably run about 5 hours. So look this up if you don't know what I mean with a DS18b20 and how to connect this to the sensor. Over here we have some functions. There is a function grab sensor temp. Sounds like this is grabbing the sensor temperature. Another one, try to delete the oldest log file. Sounds like it will try to delete the oldest log file from the flash memory. Log temp to flash. Yeah, what's probably something that logs the temperature to the flash. And there's one, send out the current temp with an interval here. And yeah, this probably sends out the current temperature to the website. Down in the traffic lights video, I talked about give the functions name that describes what they are doing. I think that worked out pretty well over here. Let's jump right into the setup. These are my standard settings on an ESP8266 for the Wi-Fi mode. Yeah, I know, probably they are default values, but setting them doesn't hurt nobody, and I'll be on the safe side with that. After setting the initial parameters, I'll go for the init Wi-Fi manager. This is a function, probably somewhere in Wi-Fi manager. Let's go through setup first, then you look into the functions, what's happening in there. After the initializing Wi-Fi manager, I'm pretty sure I'm connected to Wi-Fi, so I'll set the Wi-Fi mode to station. That's a precaution there, and set the hostname to WLAN hostname. That's the thing that was defined somewhere at the start. After that, we initialize the over-the-air update, initialize web server, initialize WebSockets. Yeah, this is a good idea to do that. Initialize the sensor. Yeah, this is really something we don't do in a function over there. Normally, I'd go for there should be a separate H file for that, header file for that, and put all the things that depend on the sensor into a header file too. As I said, this is code that's a year old, and it's a bit of a production code here, so bear with me for that. And here's the whole beauty about setting the NTP, configuring the network time protocol. This is all you have to do. Config time, I have a time zone Europe over here, because I was living in Germany at the time I wrote this. Probably I'd go now for a time zone London, because the Canaries are on the same time zone as London. And yeah, this is how you switch this. This is so simple. This is so nice and so easy. And last but not least, of course, we have to initialize the file system. So we're doing this last over here. Let's get back over here and see what init Wi-Fi Manager does. So I'll open up over here Wi-Fi Manager. So in Wi-Fi Manager.h, the local file, there's not much going on. We include the Wi-Fi Manager H, and you can tell by the pointy brackets, this is the right term, that this is a subsystem library. This is not something you find in your folder of the sketch itself. Starting Wi-Fi Manager over here, doing some settings over here. I hate the default of Wi-Fi Manager. You normally have to type 168.192.0.4 something. You see, I can't even remember this. And I set the Wi-Fi Manager address to 1.2.3.4. Everybody can remember this. And if I have to type it on my phone, 168.1, there's so much chance of having a typo in there. This is simply horrible. And 1.2.3.4, I can do this in my sleep, and everybody can do this, and it's way less chance of a typo over here. So this is my way to do this. And if you right now don't have the foggiest what Wi-Fi Manager does, please tell me in the comments, because this is something I won't go into too much detail over here, and Wi-Fi Manager is so powerful that this is probably a video by itself if we want to do this. So if you need a video for that, put it down in the comments and let me know. Let's see what init OTA does. This is probably in the OTA-H file. And again, a pretty boring one. This doesn't do much. It includes Arduino OTA. It's just simply Arduino OTA. This works on an ESP32. This works on an ESP8266. And it's always the same file. So don't ask. And I don't do really much over here. I'll set a host name, WLAN host name. It's the same name as the host name for the whole system. So it will be called WebTemp. And in the documentation of Little File System, you find a note that tells me if you want to do over-the-air update, just end Little File System before you do this. So there's a variable, a file system available. So if the file system is active, we see where this is set later, then I'll simply end Little File System here, and says this in the documentation. So who am I to go against this? After it's clear that we're doing an over-the-air update, we simply go for begin over here. Next is initialize the web server. So let's see what the web server does. It's probably under web server. Of course, we load the ESP8266 web server over here. Start a server at port 80, so it's a HTTP server. There are some handles for handle download page and handle get. And there are process index and handle not found. So init web server doesn't do so much. It simply sets up 4 pages. We have a root directory, we have a download directory, and we have a get. And of course we have a not found. And all of these are set up over here. You see found in download server H. We have a look at this later because this will make more sense when we see a bit more of the function over here. And of course, never forget the server begin. This is something that never happened to me, and of course this will never happen to me again, to forget the server begin and sit around and wonder why your web server isn't working. Yeah. All right, back to the show. To communicate between the server itself and the web page, we need WebSockets. I'll tell you a bit more about WebSockets when we get to the web page. This is all interconnected. This is horrible to explain, believe me. And yeah, let's see what the init WebSockets does. WebSockets, it's probably under WebSockets H. Yeah, you guessed it. It's another really boring page, but it's good to sort this out. If we would do more initializing over here, this would be a great way to keep everything separated so it's easier to see it and easier to understand. Here's my WebSocket server H. This is a downloaded library. This is not included in the core, but it's in your library thing. You simply search for WebSockets and you probably find this as a first thing. I start a WebSocket, and over here is an interesting number. This is a port on which the WebSocket server later will listen for the connections. So remember 38, 39, 4, we'll need this later. And of course, init WebSockets just uses WebSockets begin to start everything here. So this is done. Let's see what's left. Sensors begin, I already talked about this. This simply starts the DS18b20. Config time, I already talked about this too. This is our network time protocol. After this, everything works in the background. You simply request a time and it's already set if you have an internet connection. And then we have init file system over here. Let's have a look at init file system. This is probably under little fs because it's a file system. So include file system, include little file system on an ESP8266. Both header files are included in the core. There's an interesting global bool variable file system available, and this is normally low. And set over here to if it's available high. If I can start the little file system, I'll set this variable to high. This is my flag if we have flash memory available to write our data. You could compile the whole program without file system. So see, look over here, there's file system none, and then we can't initialize the file system. So we won't have any space to put our data to. So it's a good idea to check if we can begin the file system here. If not, we'll have a file system available at low, and we'll see this later where this is used. Another thing that little file system begin does, it does an auto format of your flash memory, the file system flash memory. Imagine you brought a new hard disk. The first thing you have to do is to format it and put a partition on it. And this does this automatically. If it doesn't find a valid partition scheme on it, it simply says, okay, this is garbled data over here. I simply format this. This could become a problem if you switch the partition scheme. And the partition scheme is a thing we saw over here before. So right now I'm using file system 100 kilobytes and over the air 422 kilobytes. If I change this to say file system 144 kilobytes and over the air 430 kilobytes, the file system starts at a specific address. And if I move this, probably the file system driver over here will probably think, okay, this is garbled data. I don't see a file system at this point, so I'll simply format it. So if you have data in your flash and you change the partition scheme over here, say between those two, you could run into problems. So experimenting with the flash size should be your first thing before you go into production and maybe change this later and lose about a week or more of data. So please be careful with that. That was it about setup. So we have everything initialized. The Wi-Fi is running right now. We have a web server running. We have the WebSocket server waiting for a client to connect that it could send data to. And we have our over-the-air update running in the background. Yeah, let's see how the machine runs all these tasks. And of course, it's down in loop. Of course, everything lands in loop. And yeah, again, pretty boring. I say that way too often in this video. So the first thing we do is server handle client. This is the web server waiting for a client to connect with a browser and requesting a page. Then there's WebSocket.loop. This is the WebSocket doing the same. This is simply waiting for, is there something to send, and it will need a continuous loop for that. Of course, over-the-air handle must be here too. And you see, handle client, loop, handle, call it whatever you like. There are two functions that we check them out now. There's one send out the current temp, and there's a 250 behind that. This is an interval. So every quarter of a second, we send out a new temperature. I have some notes over here. It takes about 42 milliseconds, and you can do this every 80 milliseconds. This is blinding fast for a web page. If you need to update this, play around with this number, maybe set the CPU to 160 megahertz and See how fast you can get this. If you do, put it in the comments. I want to know. So after we send out the current temperature, we have one thing here called log temp to flash. So this is a task that logs the temperature every minute to the log file. Let's go through these two tasks here and see what they do. You guessed it. Of course, everything in here must be asynchronous. You can't do this with any delays. So if you watch the traffic lights video, you probably will realize that this is a Ersatz delay. So this is a replacement for a delay. We simply wait for the interval. This is a, for me, classic asynchronous timer thing. If the interval has passed, we sometime later land down here. So if there are no clients are connected, we simply get out of Dodge and don't do anything. If there are clients connected, we land right here and we build up a string here that is called response, and there's a bracket h1, and then grabs sensor temp. This is a function that's probably above here. Response plus or response plus. This builds a string together that simply is called h1 temperature and a number, and a C for Celsius, and h1 again. And if you ever saw a HTML file, you probably guessed that this is something with a HTML that has a h1 and h1 closing in there. And yeah, this is one. So we build a string here, and then we go WebSocket broadcast. So we send it to anyone that's listening on the WebSocket port. This was the 3839 you remember this one later. So here's my response, and this is simply the thing that we do. We simply send it to anybody on this port. So let's see how grab sensor temp works. This is probably above here. At least a short one. So we have a float temp C equals 0. So this is probably just a initializing of a variable. And then I do a little do while over here. And you can tell by this command over here, there are sometimes glitches with the DS18b20, at least with the one I had. And it sometimes would display minus 127 degrees. This temperature range doesn't happen so much over here. So I'm pretty sure that this is a glitch, and every time I get this, I simply go through this do while loop and wait until I get any temperature that's above minus 100 degrees. After I'm sure that I have a valid temperature over here, I'll put the temperature into a string with 1 decimal point. I replace the dot that I get from there with a comma, because us Germans like commas in our temperature. You simply leave this one out if you use two dots in your temperature. And then I simply return the temp. You see over here the function returns a string type. So this is my return, and it's a string. So this, you simply grab the string that is generated by the function and push it directly into your string that I'm constructing over here. So right now the website can connect via WebSockets and transport data out of there. We grab the temperature. We have a temperature in here, and we send it out every 250 milliseconds. That's nice. Let's see how we log the temperature into Flash, because this is the next function in our loop. So here's my log temp to Flash function. And it starts with if file system is not available. Watch out for the little exclamation mark over here. So it says if file system available is not available. So this is when little file system begin can't initialize any valid partition, file system, anything. We simply get out of here because there's no point to doing anything. We can't write to anything. File system won't be available. So we get out of Dodge. Next, we know that we want to write data every minute. So we have to put all the internal NTP time things into something that we can use. This strange structure over here, but time info now carries the current time, including year and month and day of week and all the nice stuff. My time info also contains a year, and a year starting at 1900. So you have to add, if you want to have a full year, you simply add 1900 to this. So this would be 2021. If time info, so your NTP hasn't connected yet, is not synced, this will be lower than 121. So I can simply ask if the current year is below 121, 2021. I'm pretty sure that time is not initialized, or it's not initialized right. So let's get out of here, because we don't want to write anything that is garbled time information. So let's get out of here and start writing after we have synced with everything else. Here's my way to write data every minute. You see old min over here, and old min gets initialized over here as a static variable. Remember static variables? We did this all in the traffic lights video. Static variables keep their value even if you recall the function the next time. This is like a global variable, but it's inside your function. I initialize old min over here to 99. My clock doesn't do this. I don't have 99 in minutes in my normal clock. So when this runs the first time, this statement over here will never be true, because old min is a invalid minute. You can't have 99. And time info, TM minutes, will be something between 0 and 59. So on a first run, will be always true, and we always land over here. Of course, I set old min somewhere in the later code to the current minute, so that this would be true, because this is my get out of here. If old min is the same as time info, time minutes, then I simply get out of Dodge. I say this a lot. Next thing I have to do is something with little file system, and this is where you can't keep code really separated, because I have to do this in here. Over here I get a info structure from the file system. In this info structure we have a thing that is called total bytes and used bytes. And with this line I can test for, do we have space left on the file system? Because if total bytes equals used bytes, the file system must be full. If this is the case, I'll simply try to delete the oldest log file, and we have a look at this in a second. So here's my try to delete the oldest log file function, and I get a dir info, I get a next structure. It isn't written very nice, but it works, so bear with me. This little loop simply checks for the oldest file in the file system, and if it finds it, it simply deletes it. So if I run into a overflowing file system, I'll delete the oldest log file. We just saw the function for that, and then I return over here. So if I run into an overflowing flash system over here, so after I did this one, I can be sure that there's space on my flash system to write the next file, and this is probably what I'm going to do. When at last I get to this point, I update the old minute value to the current minute. So this whole function will only run every minute then. Then I build us some strings. There is a file name, fnim, that is constructed by the year, -100, because I only want to have 2 digits here. And the month, and yeah, damn you, C++. The month in C++ starts at 0. What were they thinking? Please, if anybody knows why the bleep the month in C++ starts at a 0. So January is the 0th month. It's not 1. If anybody knows why, please let me know. And of course, after this, I put in the month day. So this is 1 to whatever the length the month is, and call it CSV. I do pretty much the same with the data string with leading 0. Is a function that takes the integer number and gives me back a string with a leading 0, as the name suggests. So I'll have a hours and a minute over here, and then I grab sensor temp data. Yeah, I probably could get away with a global variable where I simply leave the last grabbed sensor temp, but this is so fast that doesn't matter in here. After here I do something pretty much textbook. I simply open the current file with a file name as a C string. Yeah, of course, you have to do a C string over here. If file name not exists, I simply close it. For unknown reasons, I can't write over here. And this is my getting out over here. If I can write, I simply print a data string. This is the one I get over here with a sensor data in here, and close it, and I'm out. So now rewriting the log file. Let's see how the web server does its thing. So when we init the web server, we tell the server what to do if a specific path is called from the root of the server itself. So if I go for the dash over here, this is what's normally called process index over here. Let's have a look at process index does. The first thing it does, it asks if the file system is available. And after this, it decides what it wants to send. There's a string that gets constructed over here. And in one instance, it's index start, then it's index link to download page, and index end. And if the file system is not available, so there is no file system, so we can't do a download of any logs, it simply leaves out the index link to download page and simply exports index start and index end. Where do we find those? Of course, in the index HTML. We have an index start over here, and the type of this is a string, is a constant string. So you can tell in here, this looks pretty much like HTML. And yeah, it is. And if you never saw a construct like this over here, you're probably wondering why I can do quotation marks in here and get away with this, because this is all inside a string. This is because of this R in front of the variable itself, the string itself. That simply tells the compiler this is raw data in here. So everything between 5 equal signs, a opening bracket, a closing bracket, and 5 equal strings is treated as raw data. The compiler doesn't mess with it. It doesn't care if there are quotation marks in there, if there are any characters in there that it doesn't know what to do with that. As long as you close the whole sentence with this, and we'll see this in a second, it doesn't care. The compiler doesn't care what it's seeing over there. So here are we closing the string with that. There's my closing bracket, and there are the 5 equal signs. You could use anything in there. You could use hashes, something, as long as this doesn't come up. As long as it doesn't come up in the string that you are encoding over here. So let me go back to that, because this would be bad. Going through the source code will be easier when we do this later in Firefox, because there we can have there we see what the browser sees at last, and it's easier to do this and then looking at this over here. This is just how to show how this is written. I don't know why not many people use this technique. I see people cobbling together really long web pages with string and string and string and string and string add and string and add. This is way easier to simply write it down, and it simply works. So now we saw how the index start and index end and the link to download page works. Let's have a look at handle download page, because this is another thing that we do. DL, this is the button that you click when you want to go for download anything. So DL is maybe interesting, and my command over here tells me this is in downloadserver.h. Let's have a look over there. So here's my handle download page. We didn't look into the H file over here, and you see there's a file count on SD and there's a linked list string over here. And these are 2 variables that get populated by these functions over here. And just by looking at the function name over here, you see get SDDIR. Yeah, this is based on some code I wrote to have a web server based on an SD card. There's actually a video down at the old channel, but it's in German, so I probably should update this too. In respect of the runtime of the video, I'll don't go into details over here, because this is enough material for another video. Man, this is getting out of hand. Just a very, very brief look at this. We get in the content of the file system directory, and then we construct something pretty much the same as we saw before with the WebTemp. We have a download HTML, we have a linked list, this is that linked list, this is this thing, and we have a download HTML end, and of course they are somewhere in download HTML. If you want to have fun and look at how this is done, be my guest. Back into the web server here, my third file is a get, and this is handle get, and this is also handled in download web server over here. This is this thing, and there's the handle get. This figures out what file you want to download, and then it goes back to send data via HTML, and there's a file name that I get over there, and this is a whole thing how to send data over HTML. All right, you're still with me, and I know this is a lot to take in, and I'm really proud of you that you're still with me here. Let's see how the thing works in action. So back to my little web page over here. Let's have a look at the source code. This is way easier to do this in Firefox or Chrome or whatever you like. You simply press Control and U, and then you can see the source code of any web page your browser is just displaying. I won't go deep into all the style stuff over here because this is simply CSS, and yeah, this is eye candy. A valid question would be that why don't you put all the CSS stuff over here? You see this here, style type CSS, blah, 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 and this is a bunch of stuff. Scroll, 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 scroll. Why don't you put it in a separate file? And isn't this better to separate CSS from the HTML file? A separate file would require a separate request for that. Your browser can handle this, but the little web server on the ESP8266, this is additional work. And if I include it all into one file, I don't have to do this. Down here at the body part, this is where it gets interesting. So there's a web thermometer stuff, and after this there's a small div over here that's called stage. And you know, this is empty. There's nothing in there, so why is it there? This, my friend, is where your WebSockets come in. And your WebSockets over here, there's a little script down here that runs after the site has been drawn by the browser. So this little script simply goes for, okay, I want to open a WebSocket connection over here with the same server that the script is coming from, under port 38394. Ha! There it is. This is the number we were looking for. This is the number we declared in the WebSocket server. If this number isn't the same as you declared in your server, the script won't work. And from here on, this is really, really beautiful, because everything you have to do from here is wait for a message, WebSocket on message. So if there's a new message, the server is telling me, hey, I have no data over here. You simply go, okay, get element by idea, the stage. So this is the empty element we had over here. And the HTML of that should be the data we get from the onMessage, the function over here. This is E, this is a function that we get back from there. So this is what the server sends over here. The browser over here simply grabs what we get from the server. The server senses, the browser reacts in this moment, and simply puts everything it gets from here down into the stage over here. This is how the value is drawn on the page. So this is pretty cool. Can I put this on the internet? Is there a way to get this out of there? Maybe, yeah, there is a way. You have to put the web server itself, so the HTTP port, somewhere on the internet, and please don't use port 80. But at the same time, you have to tunnel out the WebSocket port, so the 38394 has to be tunneled out too. If you don't do this, the data can't flow through the internet. So you always have two connections over here. You have the HTTP, which simply loads the page. And after that, you have this constant connection between the browser and the server. And this needs the port over here. Doing this on a not Fritzbox router hardware server thing, this needs some reading up there if it's doable. So that's the downside of WebSockets. You can't simply say, okay, here's the HTML page and tunnel this out into the world and it will work. You have to remember WebSockets need a separate port, and you have to open this port in your firewall, in your router, to get it out into the world. What's a good number for the port? Well, anything will do. Just choose something above 80 something. So I go for at least 10,000 something. And grab one of the ports over there. Since this is your server and you defining what data is flowing over there, there's probably nothing that can stop you from using any port over here. So there you have it. I built this project to learn how WebSockets work and get a really use case for the file system over here. We actually use this to monitor the temperature of a server over time, and especially overnight, because the 1 minute measurement interval gave us a really good resolution for that. So as promised, I will upload the whole project. So there will be a big download, including the IDE. You simply unpack it somewhere, start it, and after selecting the file, you probably have to select the one project that's in the sketchbook folder. After that, you should be able to compile this without any hassles, without any complications with the libraries. Remember library hell? Oh yeah, I remember that one. And if you do, please let me know. I'm really curious if people out there are building these projects and what they think about them. So this is all from me today, and I hope you learned something, even if this was a really complex project. I hope you liked it, and let me know in the comments. Let's talk about this. I want to know what you guys think about this. So get down into the comments and right away. All right, folks. See you in the next one, and keep hacking.